Hey everyone, we're going to identify and graph the polar equation r equals 1 plus sine of theta. Before we start to graph it, this is a cardioid and we will talk about that in a minute, but we have to test for symmetry to make the graphing easier. So the first condition is see if it's symmetric to the x-axis, namely the polar axis. So that means you take your r equals 1 plus sine of theta and replace your theta with negative theta and see if you get the same equation back. Since sine is an odd function, this can be written as r equals 1, pull this negative out here, minus sine of theta. Since it does not equal the original equation, the symmetry with respect to the polar axis fails. So it's not symmetric to the polar axis. So now we're going to try condition 2. Condition 2 is if it's symmetric to the line theta equals pi divided by 2, which is the y-axis. All right. So basically to do that, you're going to substitute in theta with pi minus theta. So we get r equals 1 plus sine of, and we're replacing it with pi minus theta. Now this is your sum and difference formula given here. So this is going to equal 1 plus sine of pi cosine of theta minus cosine of pi sine of theta. All right. Sine of pi is 0, so you get 1 plus 0 plus cosine of pi is negative 1. So you're going to have minus and negative gives you a positive, and then sine of theta. This leaves us with r equals 1 plus sine of theta, which is equal to our original equation. That means our condition 2 test passes. So it is symmetric to the line theta equals pi divided by 2. And the last test is symmetric to the origin or the pole. And this is pretty easy. You just substitute in r by negative r. So you get negative r equals 1 plus sine of theta, which it fails. So that fails. It's not symmetric to the pole. Now, the only time it will be symmetric to the pole if this was r squared. So when we have a question like that. Now this is a cardioid because it has this form with sine. My a is 1. So I could write this as r equals 1 plus 1 sine of theta. And my a is positive, and it's going to look something like this. It's either going to be down here or up here because it's symmetric to the y-axis. So now that we do that, we can due to our symmetry to the line theta equals pi divided by 2, we're going to assign values to theta from negative pi divided by 2 to pi divided by 2. So let's do that. Hopefully I can save the room. So we have negative pi divided by 2, negative pi divided by 3, negative pi divided by 6, 0, pi divided by 6. I always run out of room. Pi divided by 3, and then pi divided by 2. I'll stick that right there. All right. And then we have 1 plus sine of theta. So substituting in our angle, we're going to get 0. For negative pi divided by 3, that's going to be 1 minus square root of 3 divided by 2. That's approximately 0.1. At negative pi divided by 6, we get 1/2. At 0, we're going to get 1. At pi divided by 6, we get 3/2. At pi divided by 3, we get 1 plus square root of 3 divided by 2. That's approximately 1.9. And at pi divided by 2, we get 2. So let's go ahead and sketch the graph. The negative pi divided by 2 is here, and we're at 0. So you just go on here, you're going 0 out. Now, negative pi divided by 3, that's this one. We're at 0.1. So that's going to be really close to 0. So you go to this line here and go out 0.1. Just estimate. At negative pi divided by 6, that's this line. This is going to go to 1/2. So that's going to be half of this. So it's still kind of close here. All right. At 0, we're at 1. So here, this is small because we have this 1 here. All right, and then keep going around. We have 3.5 at what? Pi divided by 6. So that's 1.5, which is about there. And then at pi divided by 3, which is this line, we're at 1.9. So not quite 2. And then at pi divided by 2, we're at 2. So 1, 2 here. So here we go. This is this half of it. And then you can either get real specific and draw the specific lines, or just kind of come around and estimate coming back down by looking at the graph. Get closer in here and kind of draw it that way. Just estimate it. And there's your cardioid. It looks like a heart. And that's it. Thank you. Have a nice day. Bye-bye.